My name is Wim Boon, working for DNVGL, and the title of the presentation, Copper and Aluminum Compared in a Life Cycle Cost Perspective, or to be more precise, copper in comparison to aluminum as a cable conductor material. And we have, as already said, two parts, properties and related decisions, and the other part, life cycle cost analysis. The first part, properties and decision model, will be presented by myself, and the second part, life cycle cost analysis, will be presented by Remco Wal, sitting next to me. And then at the end, we will come with final conclusions of part 1 and part 2. The table of contents of part 1 is, after introduction, the typical differences between the two materials, the pros and cons of the two materials, in particular copper versus aluminium, the failure mechanisms in which these two materials play a role, a questionnaire to utilities to get information about the decision to take aluminum or to take copper, the decision makers, and opportunities for copper and conclusions. The European Copper Institute asked DNV Klima, now we are operating under the trade name DNVGL, to investigate the position of copper versus aluminium in application of low voltage and medium voltage cable conductors. DNV Klima investigated the literature about the typical properties of copper versus the properties of aluminum. And DNV Klima also investigated the literature on the typical failure mechanisms of cables and accessories related to the conductor material. We also prepared a questionnaire that was sent to about 100 utilities in 25 countries. And the questionnaire consists of 3 parts, of which in this presentation only the third part about the decision model, how to select copper or aluminum, will be dealt with. In this presentation, information will be given about the typical properties and the decision model, how to select the conductor material. Copper has a higher specific conductivity. Copper has a higher specific weight. For equal conductance, the cross-sectional area of aluminum has to be increased by a factor of 1.6 compared with copper. For equal conductance, the weight of aluminium conductor is almost half compared with copper. Copper has a higher tensile strength, higher E modulus, and a lower coefficient of expansion. And copper is far less sensitive for corrosion. For a more quantitative comparison, I show you the next. We're not going to all the numbers, but we gave copper 100, and then you see the other values for aluminum. Well, the electrical resistivity, when copper is 100, aluminum is 164. And to take another, the thermal expansion, when copper is 100, aluminum is 135. So we will not go into detail of all these values. Now talking about the pros and cons of copper versus aluminum. Higher electrical conductivity, smaller radial size, mechanically stronger, lower degree of expansion, more flexible, easier soldering, lower degree of oxidation, and a higher fatigue resistance. And the cons, we only want to mention heavier in weight. Now talking about briefly the failure mechanisms. Aluminium, the chemical reaction between water and aluminum. When water comes into contact with aluminum, you can get a chemical reaction producing hydrogen, and there were a few failures in the past related to this mechanism. Second one, the oxide layer on aluminum by corrosion. Aluminum is far more sensitive for corrosion than copper, and it gives a complication when you have in your system an insulated layer instead of a conductive. Thirdly, the thermomechanical failure due to mechanical properties. There is far more expansion with aluminum than copper, and that gives thermomechanical stresses with possible related failures. Not considering copper, we could not find a clear threatening aging mechanism. Well, this is what we have to say about the properties. Now we're talking about the questionnaire that was sent to many utilities to collect information about their decision what to take, copper or aluminium. We had a number of selection criteria: price, radial size, weight, mechanical properties, easiness of accessory installation, easiness of repair, cost of corrective maintenance. Well, this is a slight mistake. This next one must be 8, compared standard, 9, compatibility with existing cable network, environmental concern, expected problems with connectors, and any possible other factor. And this questionnaire was sent to the following countries. I don't want to mention them all, but you see it's all spread over the world, in Europe, but also in Asia, in South America, and in Africa. In the following slide, the results will be given for both low voltage and medium voltage cable networks. Table 2, the low voltage cable networks, then the medium voltage, and then I will come with the order of scores and for low voltage and the order of scores for medium voltage. Because we asked these utilities, can you give a value to the importance of a particular selection criterion? And then the number 5 is of most importance, and the number 1 is of least importance. But that was the question. In all these criteria, give a value to this particular property, and let's see what the final outcome is. Well, here you see a table. I'm not going to discuss that with you in detail, but you see here are the different questions, and this is different countries. And it's clear that, for instance, when you take here number 5, that is the number 1 was the price, and when you give a total, then you get a high number of 44. But let's not use this table because it will take too much time. I will give you a summary later on. This was the table we had for medium voltage cables, and here in this we get a summary of low voltage cables for copper and aluminum. And it's clear that for aluminum, the price is number 1, get a very high score, 44. As the next one, the company standard, is also high. When you go to copper, company standard is high, and mechanical properties are scoring high. And if you go to the bottom, the weight is scoring, of course, low, and the radial size for aluminum is scoring low. What can be expected? Here the medium voltage cables, and you have a similar order of values. High is price, company standards, mechanical connectors is coming into picture. This copper, the expected problems with connectors is much more under control than it is for aluminum. Well, to give for you a summary of these decision makers, the technical decision makers, mechanical and connector, score high for copper, as the decision makers price and company standards score high for aluminum. The following decision makers scored low: the technical decision price and weight for copper, and the repair and radial size low for aluminum. The company standards seem to play a role for both materials, and it can be explained In both situations, the company's strategy is probably decisive. Surprisingly, the environment did not play a very dominating role in this questionnaire. Well, what opportunities and challenges can be mentioned in relation to this study? Because of the material properties, copper is better than aluminium in almost every situation. And I make a quote from the BICC, the well-known BICC Electric Cables Handbook. And it said, almost the only unsatisfactory feature of copper is the way the price fluctuates. And the second quote, aluminum has become a replacement solely on the basis of cost. But nevertheless, aluminum is becoming an inevitable competitor. Copper should be promoted for the situations where it is superior in terms of improved practical use and higher operational reliability. And more work should be done to make the superiority visible and demonstrable. What challenges for copper can be mentioned? Situations that are suitable for copper are cables in ducts and conduits, cables in flexible situations, submarine cables, and extra high voltage cables with very high rating. To say a few words of ducts and conduits, when a cable has a small radial size, it can be easily installed. And the same is for the next one. When the situation in a substation, you have not much space in the cable, have to be bended in various directions, then copper is more flexible. Submarine cables, I come to that later, but we have the impression that a higher weight of a cable is an advantage. And finally, extra high voltage cables with very high rating. Yes, then there is no choice. When you take the highest conductor cross-section possible, then it's almost always copper. Conclusions. Insufficient failure data seem to be available to indicate differences in reliability between copper conductor and aluminum cable conductor. I have two sub-conclusions. Utilities do not seem to collect failure data systematically or do not want to share the information with other parties, as it is competition-sensitive information. And if utilities collect failure data, they do not distinguish between copper and aluminum conductor, and they do not consider the conductor, contrary to the insulation, as a relevant issue with respect to the reliability. Copper conductor cables are preferred technically because of lack of problems with connectors, easiness of installation, better mechanical properties, and smaller radial size. For that reason, there are still all copper utilities. However, their number is decreasing. Aluminum conductors are mainly selected for economical reasons, but additionally advantages like lower weights and compatibility with existing cables are mentioned. The utility industry seems to be insufficiently aware of the technical superiority of copper and is more focused on the initial costs. As the LCCA shows a minor difference between copper and aluminum. This will come in the second part. Remco will go into detail this. And obviously, a short-term view seems to be more popular than a long-term view. Successful long-term testing according to the present standards is not a guarantee for undisturbed long life, as not all aging mechanisms are covered in present testing methods yet. Therefore, the present testing standards are almost continuously subjected to a review process by relevant experts within CGRE and IEC. And although it was outside the scope of work done so far, there are strong indications that copper, because of technical advantages, flexibility and weight, is preferred in submarine cables, being part of a huge and growing international market. There's another point I would like to add to this last statement, that for submarine cable, the installation costs are substantially higher than for a land cable. That means a difference in material, in price, is not dominating as it is for land cable. for submarine cable, you have extremely high costs for installation. I think I am now at the end of my presentation, yes. And Hans told me that we should have now a short break for